Hi once again. So there is a few videos I was doing about resistors, and I think this is the third part of resistors. And today we are going to talk about resistors networks. So what that basically means is where you have resistors connected to each other. So in order for us to get a certain value. So with that being said, so maybe we should look at the reason as to why we connect resistors in networks. So basically the main reason for connecting resistors in a network is to get a certain value. So let's say you have an odd value, resistance value you need, like a 3 like a 3 ohm resistor, but you can't seem to find this resistor available in the market. So what do? You take a couple of resistors, you connect them in a way that you get a final value of 3 ohms. So that's what we are going to be looking at today, and we are going to look at a few boards and see how these networks are implemented. So the first so we have two resistor networks. So the first one we are going to look at is resistors connected in parallel. So for resistors connected in parallel, so we are going to use these resistors for examples and calculations. So for resistors connected in parallel, so for resistors connected in parallel, so you have to let's use two resistors. So you have this resistor here, you can call it R1, R denoting the resistor or the resistance, whatever you want it to mean. So in my case, R means resistor. So we have R1, then R2 there, so for your final resistance value, you take the resistance between point A and B. So this is a parallel connection. So you can go on add more resistors in order for you to get the value you desire. So now how do we calculate the value of this kind of connection? So for this kind of connection, this is how you calculate. So the final resistance, so the resistance across between these 2 points A, B, is equals to 1 over R1 plus 1 over R2, and this whole value here raised to negative 1. In short, you get the reciprocal of the total. So assuming that our R1 equals to 10 ohms, our R2 equals to 10 ohms. So let's just use 10. So what you do, so RAB equals to 1 over 10 plus 1 over 10. So simple mathematics. So you get 10, 1 plus 1. So this is 2 over 10. So if you do reciprocal of this, you get 10 over 2, which is 5. So you can go on adding more resistors, and you'll get your final value based on this equation. So now for the real example. So I'm going to take two 10 kilo ohm resistors and connect them in parallel. So we can just connect them like this without before we do that, let's just measure the value of each resistor. So the first one is 10 almost 10 kilo ohm. We can't get the exactly 10 kilo ohm because we have some tolerances. So assume this one is 10. So and the other one is 10. So let's connect them in parallel and see whether we have the same value as we calculated. So this is exactly the way it looks. So let's take the measurements. See, we are getting close to 5, or we can round it off to 5 kilo ohms. But in my example I used ohm, but I only have 210 kilo ohms resistors. So that's how easy it is. So you can go on adding more and more resistors. So let's go to the next. So the last network is resistors connected in series. So for resistors in series, this is where you have 2 or more resistors connected back to back. So you have a resistor 1 here. So let me adjust the light. So you have resistor 1 there. So R1 and R2. So they are connected in series. So then you have your point A and B. So you want to calculate the resistance between point A and B. So this is the simplest form to calculate, because we are just going to be adding the two values. So our RAB will be equals to R1 plus R2. So as simple as that. So if we take our two resistors connected like this, you can tell they are in series. So the first one is 10 kilo ohm, the second is 10 kilo ohms. So remember, in our last example I had used the units as in ohms, but you remember to change that, because our resistors are in kilo ohms. So R1 there is 10 kilo ohms. You add R2, which is 10 kilo ohms, and your effective total resistance is 20 kilo ohms. So let's go ahead and do the practical bit. So let's measure the value. So point A, point B. So we get 19.7. So remember the tolerances. So our value is close enough to 20 kilo ohms. So that's how easy it is. Because you are just adding the two values. So if you have more resistors, you are just going to do the addition. Now, when do we exactly apply these kind of networks? So let's say you have a couple of resistors. For example, in our case, we have two. So let's say you want to reduce the resistance of the two resistors. So what you do, you connect them in parallel. So if you want to increase the resistance, you connect them in series. So as we have just proved by these two equations. So so let's look at a board. So in a board like this, you have these 5 SMD components here. So these are just resistors, and you can tell they are all connected in parallel. So you can go ahead and sample other boards if you come across, and I assure you, you will be able to find resistors connected in one or the other kind of network. So we are going to leave it at that. So in the next video I'm going to do on resistors will be our part 4, and in that part we are going to look at how we can use these resistors, and we are also going to look at the common failure mode. So we can also look at how they fail in a circuit, and how you can be able to identify a bad resistors. So I will end it at that. So see you in the next part. So remember to share, subscribe, and also you can leave a comment. So see you next time.